Okay, this is EOC review number 4. I'm gonna go through. I'm gonna do the first one, pause, give you time to do the second one. Okay. All right, because I know some of you didn't finish the first. All right, so let's look at the first one. I had to read this twice, so sometimes you got to read stuff twice in order to get it. So the first one is saying that Barbara is considering a virtual Yellowstone Park, National Park, and she heard about an old faithful Gillier, whatever that is, and she wants to make sure that she sees it erupt. Okay. It says at one time it erupted just about every hour. And let's see, that is not the case today. The time between eruptions varied. So it erupted at different times, which is why you see it's a scatter plot, right? It's not a perfect straight line of some sort. It says Barbara went to the web and found a scatter plot on how long the erupt lasted compared to the wait time between eruptions. So along the x-axis is the erupt duration in minutes. And then along the y-axis is the time between the eruptions in minutes. Okay, you got it? The time between the eruptions. All right, so that's super important. This is X and this is Y. So we know the difference between the two. So this is the duration of the in minutes, the duration of minutes, and this is the time between eruptions. So this is the minutes, this is time of eruptions. All right, so cool. Let's do where am I at? Where am I at? Where am I at? She learned that in general, the longer the wait time, the longer the eruption. So the longer the wait time, the longer the eruption. It's an increase. That's why it looks like this. Okay. Then it says the eruption takes place anywhere from 45 minutes to 125 minutes apart. Okay. Then it says they currently average about 90 minutes apart. All right. So it says for an eruption to last 4 minutes. So the duration is 4 minutes. So that's X. So X is equal to 4 here. How long would the wait time be? And the time of eruption. So how much long would Y be? So let's look for when X is 4. So 4 is all the way here. And let's our line of best fit is somewhere in here, right? So let's draw a fake line of best fit somewhere in here. So this is I'm gonna go up to 4 on the line, right in here somewhere. So about what would that be for the duration? 80 minutes. About 80. Do you see that? So Y is equal to about 80 minutes. Does that make sense? Okay. All right. So now um let's look at B. It says what is the shortest duration time? The shortest duration time, let's look at the scatter plots. So this is the duration right here. And the point this is 1.5 right here. So somewhere in here. You see, this is the smallest point, isn't it? You see this point right here? That's a little over 1.5. So let's estimate that to be, it's between 1.5 and 2. So it's closer to 1.5 than it is to 2. So maybe 1.6-ish. So maybe about 1.6, right? You see how I'm getting that? That this is the shortest, this is the smallest point right here on the X. Okay. And then it says determine whether the scatter plot has a positive or negative correlation and explain why. Okay, so let's look at the points. It's positive or negative? It's positive because the points are going up. It's an increase. So this is a positive correlation. Do you understand how I got these answers? Okay. Are you okay? Are you okay, Allison? What about you, Kaylani? You good? All right. So I'm gonna pause for the calls and give you a chance to read over number 2 and answer. Okay. All right. So here it says a fast food restaurant wants to determine whether the season of the year affects. So they're looking for whether the season affects the choice of soft drinks that are purchased. Okay. As it surveyed 278 customers. Okay, this is the table of the results. The drink sizes were small, medium, large, and jumbo. The seasons of the year were spring, summer, and fall. Okay. It says in the body of the table, these are sales here, right here. A list of number of customers who fit both the rows and the column title. So this is basically a two-way table. We're comparing the size of the drink to the seasons. Okay? You understand? Y'all okay? All right, so these are the questions here. It says, in which season did most customers prefer jumbo? So let's look at jumbo. Which number was the largest for jumbo? The fall. So most people preferred it in the fall. It says which season is fall. More people in the fall preferred the jumbo. Okay. What is the percentage of those surveyed purchase small drinks? So small drinks, how many people purchase a small drink out of everybody? 64 on the end. You see that? 64 people. 64 people out of how many surveyed? 278 people. So to find the percentage, you write the fraction first, and now we're going to divide to figure out what the percent is. Second plus 712. All right, so we got 64 divided by 278, and that decimal is 0.23. How do you write 0.23 as a percent? And so what percent is this going to be? 23. This is 23%. Okay? Y'all okay with that? Then it says, what is the percent of those surveyed purchase a medium drink in the summer? So we're looking at summer. Okay? What's the fraction there? Medium drink in the summer. How many people purchase a medium drink in the summer, though? Out of how many? Out of 98. You see that? You see how to write that? Okay. So now we have 28 divided by 98. What's 28 divided by 98 as a decimal? Yeah, you go get count. And what does that give you? Type it in. Do it for me. 28.285. So move the decimal over 2 times. So this is going to be about 28.5%. Got it? Oops. Make sense? And then, what do you think the fast food restaurant learned about the survey? Remember what they wanted? They wanted to determine whether the season of the year affected the soft drink. So let's look at the seasons. This season is 81, 98, 99. What does that tell them? People purchase more in the fall, but not by much, is it? So is there a major difference? No, there's no major difference. That's what they learned. That's really not a major difference. Does that make sense? Okay. All right. I'm going to pause, give you a chance to answer the bottom 2, 3, and 4. Okay. Y'all all right? Yes. All right. So let's look at it. Here it's saying the Environment Club is interested in the relationship between the number of canned beverages sold in the cafeteria and the number of cans that are recycled. So the number of canned beverages sold is X, and the cans recycled is Y. Okay. All right. So we're finding the equation for the line of best fit. Excuse me. Thank you. So we're going to clear it, 2nd plus 712. Then I'm going to go to stat. I'm going to go to edit, and I'm going to type my X values in, which is going to be 18, 15, 19. Is that 8? 8, 10, 13, 9, and 14. Then go over to X, and we got 8, 8, 10, 6, 3, 7. Huh? Which one? Where we at? This second number right here is 6? Okay, thank you. Okay. This is 7. What's that number? 5? Okay. And then 4. So small. Thank you. All right, so we got those numbers in. So after we type the numbers in, where do we go? Where do we go to do linear regress? I remember? We're doing the line of best fit. We just did that today. Stat, then where? Calc, then where? Linear grid. Okay, I'm going to press enter. This is the equation. So I'm going to truncate. I'm going to cut the decimal off after 2 spaces maybe, okay? So I'm going to make my slope 0.39, okay? So this is y is equal to 0.39x, and then this is 99.1 plus 0.991. I'll do that. Okay? You got it? Okay. So this is my line of best fit. Are you okay with it? Would you do 1? Yeah. That's fine. It's not wrong. Okay. All right. So let's look at number 4. This scatter plot suggests that the relationship between the variables, the age in years, and the income. So age is X, and the output is the income. Y is the income. All right. So let's see. What type of relationship does this suggest? Okay. Is it positive or negative?
Positive.
Definitely positive. Is it weak or strong? It's strong. Okay. Any questions about that? The points are close to that line. Okay. Is it close to the line? Okay. You got it? All right. It says, what is the domain of ages? What is the domain of ages? That's what are your X. Your smallest age. Look at the points. What's your smallest age, and then what's your largest age?
18, 60.
18 and then 60. Yep. So it's from 18 to 60. Another way to write that, 18 less than or equal to, and 60 less than or equal to. It's between 18 and 60. That's how you write between 18 and 60. Got it? Does that make sense? If they're writing it separately, sometimes you might see it separately. X might be here. Then X is going to be this, right? Because the mouth is open to the X. And then this. So separately it looks like this, but together it looks like that. You got it? Okay. You see how the mouth is open to the X here, and the mouth is open to the 60 here. Because 60 is bigger here, but X is bigger here. It's less than the 18. Okay, I mean greater than 18. All right, the range. What is the range of incomes? Okay, what is the range of incomes? All right, so looking at the range, what's the lowest income to the highest income? What's the lowest income? That's this way. What's the lowest point? And then what's the highest point? 10, yep, to 70. So that's the same. You got from 10 less than equal to Y, 70 less than, it's between 10 and 70. Does that make sense? Okay. Are you okay with that? And it says, do you think age causes the income to increase? It's not a direct cause, it's a correlation. Okay, if a direct cause, like what we talked about, this class didn't get to talk about causation, but if one variable causes the other to happen, then yes, that is like alcohol consumption causes DUI. That's a cause. That's a direct cause, but it may affect it. If it's affecting it, but it might not cause it directly, then it's a correlation. But if it causes it directly, that's causation. That's what this is asking for. Does it cause, is it a direct cause? Not really. The line would be probably straighter if it was a direct cause. But it's a correlation. Like it's not the only reason. Like age is not the only reason that the income is going to go up. Do you see what I'm saying? So it's not causing it directly. Does that make sense? Okay. So this is a correlation. They correlate. It's a correlation. The older you get, yes, you're gonna spend more money, but not causation. It doesn't directly cause it. Got it? Y'all okay? Okay. So now I'm gonna pause, give you time to answer. Well, no, we can do that one. Dot plot. Okay. So now we're gonna make a dot plot. Remember when you're making a dot plot, you have a number line. So these are the numbers, the heights. It goes from 42 to 48. So we got a number line. We got 42, 43, 44, 45, 46, 47, 48. Okay, so it goes all the way to 48. Make sense? Now you're going to put a dot above how many they are. That's the frequency. The frequency is how many. So how many 42s are there? So you're going to put one dot. You okay? How many 43s are there? So we're going to put two dots. Does that make sense? How many 44s are there? So we're going to put four dots. How many 45s are there? So we're going to put five dots. Is that all right? How many 46s? Four. How many 47s? Two. How many 48s? One. What is the shape of this? Is this approximately normal, skewed to the left, or skewed to the right? This is approximately normal. That's where the numbers are clustered in the middle. Oops. Are y'all okay with that? Okay. If the tail is on the right and it's pushed to the left, clustered on the left, that's a skew to the right. If the cluster is on the right, it's skewed to the left. It's crazy, but that's just the way it is. All right, so now we're gonna make a histogram. Do the same thing, only histogram is numbers on both sides. Okay, so we'll start with 40, 42, 43, 44, 45, 46, 47. It goes up to what, 48? Okay. So along the highest frequency is 5. So it's 1, 2, 3, 4, 5. So 42 has 1. 43 has 2. 44 has 4. 45 has 5. 46 has 4. 47 has 2. And 48 has 1. So you see how even though it's a histogram, you still have a shape of approximately normal. Does that make sense? Kaylana, you okay with that, baby? Okay. Now we'll make a box plot. You ready? Okay. So let's type these numbers in the calculator. Second plus 7, 1, 2. You ready? All right, so go to stat, edit, and we're going to type these numbers in. Okay, so we can do our 5-number summary and figure this out. How many 42s do we have? So type in 42 one time. How many 43s do we have? 2. So type in 43 2 times. Got it? How many 44s do we have? So type it in 4 times. 1, 2, 3, 4. All right, 45s. 5. 1, 2, 3, 4, 5. 46. 4. 2, 3, 4. 47. 2. 1, 2. And 48. 1. Okay. Got it? It's 19 numbers. Let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's 19 numbers. Got it? And I just went down one, so it says 20, but there's nothing there. Okay. So now we're going to do the 5-number summary. So we go to stat, go over to calc, and it's the first one. Enter. And the numbers are in list 1, so press second 1 and enter. You got it? So now we're going to find the 5, we want to do box plot. So we need to know what the lower extreme is. We need to know what the lower quartile is. We need to know what the median is. We need to know what the upper quartile is. And we need to know what the upper extreme is. That's your 5-number summary. Got it? So press the down arrow. This is your lowest number in the list, min X. So that's 42. Press the down arrow. This is your lower quartile, which is 44. Press the down arrow. Your median, MED, is 45. Your lower quartile, down arrow, 46. Down arrow, your maximum number is 48. Got it? That's your 5-number summary. Does that make sense to you? So we're going to draw your number line. And you got those numbers on it again. 42, 43, 44, 46, 47, 48. Okay? So we're going to put dots above these numbers. The lower extreme, 44, 45, 46, 48. Got it? So now you draw a line, your whiskers here, as we used to call it, in here. A box from quartile to quartile. And a line down the middle of the median. Got it? Does that make sense? Okay, so if it asks you for the 25th percentile, this right here is the 25th percentile. If it asks you for the 50th percentile, this would be the 50th. Okay. If it asks you for the 75th percentile, this is the 75th percentile. Got it? Okay. All right, I'm going to pause to give you a chance to read Read and answer that. Y'all okay so far? Okay. All right, let's look at it. Let's look at this one. It says the school is having a coat drive for a local shelter. The teacher determined the median number of coats collected per class and the interquartile range. That's when you subtract the quartiles from each other. Um, of the number of coats collected per class for the freshmen and for the sophomore. Okay, so let's look at the freshmen first. The freshmen collected a middle number of 10. So their median is 10, right? So the MED, let me put MED at the top. So the MED of the freshman class, we're going to compare the two. The MED of the freshman class is 10. Okay? And then it says that the interquartile range is 6. So if it's 6, cut 6 in half if that's the middle number. If we cut 6 in half, then what's half of 6? So it's 3 on this side, right? And 3 on this side. So if we're doing 3 on this side, what would this number be? 13. And then 3 on this side, what would this number be? 7. Okay. So this would be your lower quartile, right? And this would be your upper quartile. Make sense? Okay. So let's do, what is it, sophomore? So sophomore, it said that the median was 10 again, right? And so this time the interquartile range is 4. So if we cut 4 in half, what would this number be over here? 12. And what would this number be over here? 8. Okay, does that make sense? Okay, so then it says, which range of numbers include the third quartile? So third quartile, which range of numbers include the third quartile codes collected for both? So the lowest third quarter number is 12. So it has to be D, doesn't it? You see what I'm saying? It has to be D because you want to include them both. So this is where the third quartile would be. You see what I'm saying? Here. So it has to be D. All right. A reading teacher recorded the number of pages in an hour each student read. The numbers shown below. These are the numbers here. For this data, which is not correct. Okay, so you can still do, look, second plus 7, 1, 2, and you could type in the numbers. And the numbers are 44, 49, 39, what is the next one? 43, 50, 44, 45, 49, 51. Okay, and we got stat, calc, this first one right here, list is in 1. So now it's asking for your lowest number in the list. Your lower quartile is 39. This is true. Go down one more. Your lower, well, this is the lower extreme. Your lower quartile is 43.5. 43, that's almost 44. So we're going to put a star. It's not perfect, but it's almost right. Go down. Your median is 45. That's right. And your maximum number, go down, max is 51. So which one is the one that's not right? B. Okay. You see it? You got to choose the best answer. That's why I did that. All right. So number 3, a science teacher recorded the pulse each day of the students in the classes. After the students had climbed a set of stairs, she displayed the results by the class using the box plot shown. Which class generally had the highest pulse? And the one that had the highest pulse, we said, let's see, was class 3. And we said it's class 3 because this class has more kids that have a higher number of pulse than these. You see the lowest pulse here is around 75, 76. And all of these numbers are smaller. So these kids had higher pulse than the other kids on average. Okay, so that's why it's class 3. Got it? What time is it? All right. Let's look at the back. It says Peter went bowling Monday to Friday, 2 weeks in a row. He only bowled one game each time he had went. He kept track of his scores below. This is week 1, this is week 2. What is the best explanation why Peter week 2 mean score is lower than week 1? All right. So why is week 2 lower than week 1? Why is week 2 lower? What happened with week 2? What makes it lower? Yeah, it has 64. Okay, so it says Peter received the same scores 3 times in week 1. Peter, I mean, he did, but that's not what's making it lower, right? Peter had one very low score in week 2. Yeah, that's a good answer, isn't it? That's the better answer. Peter did not beat the high score from week 1 and week 2. No, not beating it is not the real reason. And Peter had one very high score. No, having a high score is going to make the score go up, right? So the best answer is B. This histogram shows the frequency, that's how many in a distribution of duration times for 107 consecutive, that's back-to-back eruptions of old faithful. How you say this word? Y'all know that? Geyser? Is it geyser? All right. The duration of the eruption is the length of time in minutes. Length of time in minutes. From the beginning of the spewing water until it stops. All right. What is the best description for the distribution? So look at this. Is it A, bimodal? Is it ununiform? Is it multiple outliers? No, this is not it. Skewed to the right. You see how it's high on this? It's got one that's high on this end. Okay, and then the rest of the numbers are clustered here. And I didn't know that they were going to actually use this vocabulary word, but um, it is bimodal because it's high on both ends. Does that make sense? It's not a skew to the right because you got all of these frequencies here. Does that make sense? So yeah, this is a word that I didn't realize they were going to be using it. They never used that before, so that's kind of weird. All right. Let's see. Which graph most clearly displays the set of data for which a quadratic function models best? So which one of these looks more like a quadratic function? A, B, C, or D? A. A is a U-shaped line. Remember, linear, straight, uh, curved line, up or down is exponential, but a U-shape is quadratic. It says to rent a carpet cleaner at the hardware store, there is a set fee and an hourly rate. So the set fee is the starting amount, and the hourly rate is the slope. The rental cost can be determined by using the equation when a carpet cleaner is open. Um, when a carpet cleaner is rented for X hours, H is the number of hours it's written, and C is the total amount. Okay, which of these is the hourly rate? So which of these amounts is going to be the rate that they're going to pay for each hour? Are they going to pay 3, 3H, 25, or 25H? 3. Just 3 is the slope. Okay. Number 8, it says the graph plots a number of wins in 2006 season and in 2007 season is a sample of the professional football teams. Which equation best matches the trend? So we're looking for the line a line of best fit. All right, so we can graph it. All right, so the y-intercept here is 2. This is 2. Crosses at 2. And it's going up. The slope is 1 over 1. Okay, so b is 2, and the line goes up 1 over 1, up 1 over 1. So up 1 over 1, up 1. Let me just do 1 point. Up 1 over 1, this point right here. If you do that, then you can take a straight line and just connect those 2 points. You don't have to keep going. Just take a straight line and see if that's a good line of best fit. So just graph 2 points. So now, is that a good line of best fit? I'll leave it. This is the first line. Okay. The other one, this one, B is equal to 7, and then up 1 over 1 again. Okay. So 7 is, where's 7? Right here. And go up 1 over 1. So, is that a good line of best fit? No, definitely not. Okay. That's definitely not. Mm-mm. The second one, it starts at 1, and the slope is going to be 3 over 5. Jesus, take the wheel. All right, so start at 1 again. Not again. Is it again? No. So 1 is down here, and we're going up 3. So from 1, 3, that's going to be up 4 to 4. And it's going to go over all the way. It's going to go over to 5. This is 4 here. 5 has to be here. Is this one a better line of best fit? This is the third one. Okay, and then the last one, it starts all the way up here at 5. And then it is the same slope, 3, 5, that's all the way to 8, and then over to 5, 4 here. 5. So now you have to choose between those 3 lines. Which one is the better line of best fit? We already eliminated B. Which one of these you think is the better line of best fit? The line that's in the middle. Which one do you think? You said C? That's this line right here, right? This one? It's not the last one. That's too steep. It definitely was between these 2 lines right here. So you think it's this third one here? Let's erase it to see. You think this line is in the center? 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5, 6. Dang, that is close, ain't it? Yeah, I can agree with you there too. I didn't realize it was that close, to be honest. See. All right, so this one, the graph plots the number of wins 2006 to 2007 season for the sample professional football teams. Based on the regression model, what is the predicted? So we're using y is equal to 3 over 5x plus 1. What is the prediction for 5 games? So we substitute 5 games. Let's see what we get. So plug in 5. 3 over 4. And let's do times 5 plus 1. What does that give us? 4.75. So that is going to be what? A. Let me see. What if we would have chose the middle one? What if we would have chose? What if we would have chose? No, that's probably the better one. That's right. All right. So what's the last one? Not the last one, but what's this one right here? Is this a positive or negative? Definitely. So mark these two out. So now you have to figure out: is it weak or is it strong? It's kind of out, isn't it? It's not as close together. I really feel like this one's a weak. Okay. Yeah. I mean, it's going down. It's a week. Yeah. All right. Which of these statements is example of causation? Remember, it causes the other to happen. So it says when the weather becomes warmer, more meat is purchased in the supermarket. Okay. All right. More people go to the mall when students go back to school. The greater the number of new TV shows, the fewer number of moviegoers. After operating costs are paid at a toy shop, as more toys are sold, more money is made. So which one is going to be a direct cause of the other? D, definitely. That's it. D. The rest of them are correlations, but they're not direct. Does that make sense? Okay. Goodness. Y'all got it? So this one is EOC 4. All right.